So what is caching? Now take the normal flow for your app request. Your app sends a request for data. The server asks data from the database. Database runs the query and sends back to the server. Now server builds the response and send it back to your mobile app. That's an expensive trip. Your mobile app does that on every screen, even though when the data is unchanged. So caching means storing a copy of some data so you don't have to fetch it again and again. Now caching can live in two places, the app side caching and the server side caching. The server side caching, server can catch the expensive result. Server can catch frequently asked data from the client side. So now your server don't have to run a heavy query and it can answer much faster. And if there is no data found, it will send request to DB and it store it into caching. So next time server asks, it will have it in the caching layer. It's a big topic, but that's a high level overview of server-side caching. Next is app-side caching. On the app side, app stores the data on the device, so it don't have to ask server at all. App can store some frequently asked data. App can store some heavy usage data. So app sends the request, and if found in caching layer, caching sends back the response without sending a request to server at all. Now let's talk about why caching matters for your app. There are three mainly reasons. First one is the speed. When there is a cache data, it loads the data instantly without showing a user a loading dialog. Second one is the cost. Now you are not re-downloading the same response again and again, which saves the server cost and the battery. Third one is the connectivity. If user loses the network for a few minutes, user can still use the app and not stuck with the loading screen. There are mainly two types of caching, in-memory caching and persistent caching. In-memory caching is the simplest and fastest caching. Here are some pros and cons. In-memory caching is the fastest, but it uses your app RAM, so make sure you are not storing any big data on it, and we are storing the value in memory. As soon as your app closes, you lose the data. Let's see an example. Here on a load, I'm loading a simple list with some static data. So next time if I click on a load, it should return the data instantly. As you can see, I have a simple cache variable. As soon as I get the data, I store it inside a cache, and next time I'll make sure if there is a cache data, I'll return it. This is really useful when you want to store a small set of data across your app lifecycle. Second, persistent caching. Persistent caching stores the data on a device. There are multiple ways you can store the data on a disk. Persistent caching survives the restart. It works offline. Cons are, it is slower than your in-memory caching, since we are storing inside device storage. The more data you save, the bigger your app size gets. Here are few ways how we can use persistent caching. Now let's start with the shared preference. Shared preference is used for a small key value pair setting, such as a setting value and user preference. For the structured data, for a real object, large list, use database. You can use any database out there. You can use Hive for a fast key value object storage and SQLite when you need queries and relations. Third one, HTTP cache. You might be already using this. This stores a response by its URL and serves the stored copy in the next call if any error. There are packages available for this. You can use DO Cache Interceptor or Flutter Cache Manager. And lastly, image cache. It has the same idea. It writes your image into a disk, so you don't have to download it again and again, the big images. Now let's see when to use caching and when not to. Caching isn't free. Every cache uses memory or disk, add code to maintain, and brings the risk of showing the data that is out of date. So don't cache anything by default. Use cache only where it's actually needed. Here are some thumb rules when to use it and when not to use it. Use it when any kind of data that gets read again and again, such as a profile screen or user images. You can just fetch it one, keep using that one. Across app lifecycle, any kind of app config or feature flag, and any kind of product catalog and home feed. Now, when not to use it, anything related to payment confirmation status or anything related to payment always reflect what you are getting from the server side. Any search result queries, any kind of live balances as account balance, live score, you always reflect what you have on the server side.